Hi, Rahul.
Hi, sir.
So, what is this presentation today?
This is presentation regarding the real-time fraud detection. That is, it is useful in the fintechs, in fintech domain for detection the fraud with the help of agents in real time.
Okay. Okay.
Uh, so, okay.
In
So,
non-cloud, right? It is on
yes,
non-cloud or?
yes, yes.
Okay.
It is on non-cloud.
Okay. Okay. Go ahead.
Okay. So, hello everyone. My name is Rahul Patil, and I'm from Mumbai, and this is my LinkedIn ID. And this presentation done under the coach of the coach Shishanti Kumar V, and here is a sir's LinkedIn ID. And this presentation is regarding the real-time fraud risk score engine that use modular AI agent, synthetic data, and full auditability to transform how we detect a response to fraud. And this help in reduce our cost by 40 to 60%, and reduce the workload also by 90%. And it help in delivering the companies to detect the make the decision within 2 seconds. So it this type of value can be built in our organization. So this is all about the these projects. So moving to second slide. Um, Manual fraud detection, here you can say the in challenges in manual fraud detections. Manual fraud detections are very slow, and that is a slow, expensive, and error prone. So, not only in fintech, as we can see that e-commerce, fintech, e-commerce banking, we are process around 10,000 or millions of transactions daily, but only tiny fractions are truly fraudulent. So, so every transaction go through the same manual scrutiny. So the result will be there is a most more false positives. So it wastes hours of times, and real frauds slip through because analysis are overwhelmed. Then here is a delay decision making, also we can say delay decision making. And one miss incident can cost millions of the losses, fines, and reputation damage also for the company. So manual process, as we say, manual process uh, cost 40 to 60% more than automation, and that is not suitable. So we need to intelligent automation, and that we are building. So these are the current pain point: no real time scoring, then no repayability, no synthetic testing. So these are the problem statement and real pain point we face. So moving forward to third slide. So uh, in risk analysis, if anyone want to risk analysis, focus on a high risk case only, not drawn the low risk noise. So he's only focusing on a higher risk, not drawn to low risk noise. So independent. So this is a we can say that this is a user story format that invest. So invest in independent. We can say negotiable, valuable, estimatable, small, and testable, default testable. So manual screening the thousands of transaction, guess risks without evidence, loss, audit trail, be unable to test edge cases. So instead of this, we want real-time scoring, clear risk labels, evidence, and full audit logs. So so one click alerts we want. So acceptance criteria will be the score transaction. We can see the less than to score any transaction less than 2 seconds, and return risk labels plus evidence also. Reply any past transaction for replay any past transaction and debugging. So so wait, put debugging. So generally 100% synthetic data transaction for testing. So these are the main acceptance criteria. So we want user story format. We can say the invest means invest in suspicious, then very risk score with the evidence and policy snips, simulate fraud scenario with synthetic data, no manually screen every transaction, export audit logs for compliance and track alert actions. So this is the third slide. So fourth slide is demo objective. So demo object is what we fully automate auditable testable fraud scoring engine for raw transaction alerts and the audit log. So here are the score criteria, means score any transaction under 2 seconds done. So here we return the low, medium, high evidence persistence score, replay any transaction for the debugging, and generate 100% realistic synthetic transaction done. And these are the not, and these are the compliance which are not negotiable. So here we use the synthetic data modular agents. There are 4 agents: fetcher, scorer, persist, and alerts. There are agent for the do the this task. Langraph for the uh, flow of our process, and audit logging we use SQLite and JSON backup, and then debugging the production issue. So these are the demo objective. So success metrics: what score less than 2 second, risk level low, high, medium. Then for audit trial persisted to database. So these are the success metrics, and this is the most of the demo objective. Then so here you can see the function requirement. Here in this function requirement is we require the transaction data. We have to score risks 0 to 100, use rule-based logic, amount, location, and velocity. So these are the logic we use, and these are the this decided by the agent itself. Returning policy snippets, matching risk factor, and sorry, risk factor, and trigger alert if high risks. And the perform, and here are the metrics. So metrics for the uh, means performance, auditability, scalability, reliability, testability, and scrutiny. Next is cost comparison. Cost comparison means every time means in industry we what we process the millions of uh, transaction daily. So uh, so with automation we can decrease this cost very heavily. So manual process 15 to thousands per hours for analysis time, 5 to 10 minutes for transaction, and 30-35 false positive rate. So this is very high. So with the automation we can score up to 90% of transaction automation, review time within 10 seconds, and cut false positive by the we can say 30 to 35%. So in overall scenario, automation reduce the fraud operation caused by the 40 to 60%. And so annually we can say the 9,000 manual review saved daily, and 750 hours also saved daily, and $37,500 saved per day, and that's 13.7 million per year from the one system. So this is the ROI you can get with the help of this automated risk scoring engine. Now, next slide is empower analysis to focus on high impact work. So here before and then after we have comparison. Instead of reviewing 1,000 transaction analysis, view 1,000, but those thousands are one that matters. So before we open dashboard, filter transaction, check IP address, device, merchant, cross reference policies, we can say, decide and log the spreadsheet. So it will take 5 to 10 minutes for per you can say per case. And then uh, after after this then with the help of automation, synthetic flag is high risk only. Synth so system flag high risk only. Then here we can get score and evidence also. One click ticket created also, one click ticket created, and auto log will be generated for the any high risk transaction. So it will be take 10 second per cases, which is 30x faster than the uh, any legacy system. So here we can increase the 10 second per transaction, you can say that. Then next is architecture. We can say the diagram with agents, then line graph here, and then agents, line graph, then SQLite. So here are we build the modular agents. So fetch agent, score agent, persist agent, and alert agent. For this is the agents, and line graph for manage workflow, handle retrials, validate output with Pydantic, and catch the error with the help of line graph we have to do. And the auditability with the help of every step logs to SQLite, fully backup in JSON format, and replay any run with 100% fidelity. So here we can say, so tech stack is this, means here we can use Python, LangGraph, Pydantic, SQLite, and the API. So in future we can use here Kubernetes also, and we can use the Kafka for the in future perspective. Now next is this is our phase one. This enhance the score engine. Here we can use the add rags integrated with LLM and add velocity analytics, enhance the scoring engine for the purpose enhancement. And real time, as I say, real time integration, we can use the Kafka and deploy with the Docker and Kubernetes. And the we can set the email alert, SMS alert in real time. And with the help of advanced analytics dashboard, with the help of Streamlit, we can give. And the score risk distribution also we can show with the help of dashboard. So these are the we can say the enhancement we can make in this. And then next is this POC prove we can automate fraud scoring. Then we can scale it also. So uh, uh, so fully we can say that this is a key achievement. This is a fully functional engine, production ready fraud scoring solution with audit capability, 90% time reduction. So manual review from 5 to 10 minutes to 10 seconds. Then cost saving also, as I say, 75 75 $3,700 $1,000. And next step, so start with business. Start with one business unit at credit card processing, gather feedback, and testing also we have to do on 100K per synthetic transaction, and pack with a Docker image and deploy. So these are the next steps. And so this presentation, what do we deliver? We deliver the uh, uh, pain point where losing 1 million, means imagine losing 1 million on fraud because of we are missing red flags that are shown, but our manual scrutiny are not evaluating it properly. So this is one pain point. Um, and then in my now in demo Python, I show you the transaction presentation also, how giving this transaction and how it show the output is showing. And then these are the and we can see the this help in the reduction of the business cost and help in a grow the business in automate manner with less human interference is required, and it help in the grow the business very less mistake, we can say. So these are the my now presentation, and this is the sir, under the Shanti Kumar V sir guidance, we are delivering the this presentation and this demo. So now I move to the my project setup. So here you can see the this is my project setup. So this is all agents. Here is audit, and here is data. Then this is my environment, virtual environment, and here's orchestrator, and here is a test agent for orchestration and replay. So in the here is a main part come in here in agents. In agents there are one fetcher agent, then scorer agent, persister agent. So wait, we and this alerting agent is fourth. So in the fetcher agent, what you do, um, this script load the synthetic financial transaction data from JSON file and provide a functional retrieve details information about specific transaction. So wait, this provide all the transactions detail, and on the return give a transaction ID, and the means transaction detail means amount of time spent merchant user. Here you can say transaction detail is load the data. Here you can give the transaction detail, user profile, name, risk level, account, age, it provide, and profile and information this provide. So simulating the real world data access for a fraud detection, risk scoring. um, uh, so so in this matter agent is important, uh, and enable reproducible testing with the structure and realistic synthetic data. So this load the synthetic data with the help of and this is done by this agent, and these are the libraries. These are libraries we initially use for the import, and store result are stored in the this result file. Then next is a scorer. Scorer means this second agent rule based, you can say, risk scoring engine. This second rule based risk scoring agent means it analyzes transaction context from the agent one, that is a result fetched from the agent one, and calculate the risks between 0 to 100, we can say 100, with the clear label low, low, where is low, high, and the medium. This determine the score high, medium, and low, and recommend relevant compliance or security policies at simulating rack. So these are the rack means written policy snip match risk factor and real system. This would be query with vector database, and these are the get policy snippets here. And here lastly we get the score transaction and give the score means risk score. Here, risk scoring is so high amount means what means there is a new device found, there is a we can say the new there is a transition done by the new device, there is a velocity means how much transition to perform, and merchant category. So here you can say the electronics category, financial service, which type of category here is in this scorer engine determined in this code snippets. Now third is persister. This more agent 3 safely store the risks assistant generated by the agent 2, means here you can say database, and into the SQL database, creating a permanent and queryable audit trail for every we can say the transaction review. So here the transaction reviews are stored in the audit trail. Means if the same audit ID is processed again, it update the record instead of duplicating. Means not only this, there is a schema. So it is not only the same transaction process again, it update the record instead of duplicating, and ensure the data consistency it appear in the data set. Why this matter? Means every risk decision is log and critical for compliance, we can say. Analysts can query historical decision to tune the level or investigate fraud. So scalable with the help of SQLite work with prototyping and use prototyping, and this pattern can adapt easily with the, you can say, the Azure, we can say the PostgreSQL also. So these are the we can say the persister. Here is schema, where you can all these transactions store in the SQL database, and here is the alerting system. Here you can see the alerting system to provide the generate the alert ID on transaction. So now I am going to show you the wait. So here you can see that this is my Streamlit dashboard. Here is a name is Real-Time Fraud Risk Scoring Engine. So AI power detecting with synthetic data and synthetic data. So here this is a transaction, and user is I take Streamlit user, and if I run this fraud, means this transaction. So this for this transaction, we can get the risk score is 60 and with medium. So what this type of transaction is an international transaction. So either do with the new device detected and unusual merchant category. So this is a category is unusual, so you can say the risk score is a medium. So, and cross-border transaction trigger here, and first time device use require you can policy, this is a policy snippet also provided here. And agent, this fetcher, scorer, and these agents are giving their output, means transaction, user ID, amount, how much transaction done, merchant, which IP address, which category is it is, location, country, and city. So these are the all the profile as means evidence is given by the transaction. And here scorer also define the which type of agent score is risk how type of 60 medium, internet transaction, and new device. So and policy also it is present. So these are the these are the front end of this risk scoring engine, which is used in the real time decision making in a fintech company. For with the help of agent, we can detect the any transaction fraud. Okay, sir. This is my conclude point.
Okay, Rahul. I'm stop.